Hi guys, a very good evening everyone. Welcome to the session and welcome to the special series for you, that is the IISC Bangalore previous year question series. Yes, we all know that IISc Bangalore is going to conduct the upcoming GATE 2024 examination, and what were the questions asked by IISc in its previously conducted years, that is 2016, 2008 and 2002 respectively. Okay, we are going to have a question discussions among all of these years. This 2016. Yes guys, very good evening. Quickly everybody keep joining and keep sharing the session to all the GATE 2024 aspirants, you know. Okay, so we'll discuss a digital electronics question in this particular session of these 3 years. We'll go chapter by chapter and move on, and we'll try to cover till the end. All right. Yes, very good evening. Chalo, so let's get moving ahead. This is a regular introduction that you are all aware about. Yeah. Yes guys, so whatever we are going to discuss in the session, as you know, I'll be sharing the PDF, okay, of today's class with all question and the solution. And to get the PDF, you can join my Telegram group with the link mentioned here. I'll also share the link in the comment box in some time. And also, you know, to get daily dose, important questions, latest information about the exams, notification of the class, important PDFs, and for clearing the doubts by experts and even your friends, being interactive in the group. Also guys, you know, the UPSC ESE 2023 mains results have been declared, and yes, if you're one of them selected in the ESE mains but looking for a proper interview guidance, so share your result and you'll get free mock interview, okay, with the expert panel, which is very much similar to what you can expect in the UPSC Engineering Services examination. Many students got benefit in the last year as well, so you share now and the link is in the description. Okay, and also guys, those who want to attend some of the other classes, so there is this free app live classes scheduled for me. This is for this week. Okay, so we're having some random quiz and questions in the digital circuits. Okay, that is number systems, logic gates, combinational circuits and sequential circuits daily on the BYJU'S exam prep app. This is the app schedule for me for this particular week. Okay, you can tune into live daily at 7 p.m. Tune into live daily at 7 p.m. All right. Okay guys, so let's get started now quickly guys with the questions. This is the number one on the cards. Okay, the two numbers represented in signed 2's complement form are P and Q given to you. If Q is subtracted from P, what is the value obtained in the signed 2's complement form? If Q is subtracted from P, so what is the operation they are looking for? Okay, they are looking for an operation of the form P minus Q if Q is subtracted from P. And in such cases, because it's a digital machine using signed 2's complement form, P minus Q could be written as P plus minus Q. And whenever you want to take minus Q, you know, you can take its complement, right? It may be already in 2's complement form, but to represent minus Q, when negative or negative will become positive. That's it. What I want to say is that whenever there is the minus Q, take the complement, take the 2's complement. That's what we should know. Okay, so what is the value of P? The value of P is as given 11101101. And what is the value of minus Q? Okay, Q is given, minus Q means 2's complement form, and when you want to take its 2's complement, first I will take the 1's complement. 1's complement means invert each and every bit. Okay, so 0 0 0, then 1 1, and then 0, and then 0, and then 1. This is the 1's complement, right? And then we add 1 to the rightmost digit. Okay, and when you add 1 to the rightmost digit, okay, this is going to become 0, 1 will become 1 0, so I will correct it there. This is the 2's complement. This is the 2's complement version, right? Okay, so we have an answer coming up as C. Let's check out, and now I'll just add. I have to add P and minus Q. Okay, so I'll just add bit by bit. 0 1 plus 0 0 plus 1 1 plus 0 1 plus 1 0 carry 1 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 1 plus 1 0 carry 1. The last bit will be discarded because it is a 8-bit machine clearly represented by the values given. So answer is 0 0 0 0 0 triple 1. Answer is B. It's not C. Okay, the answer turns out to be option number B. Okay, 0 0 0 0 0 triple 1. You know, there is another method. Alternate method is, okay, but that will be, I think, this is simple. Alternate method will be convert P and Q both to decimal, and then you can do P minus Q in decimal. In decimal it is easy, and then you can convert back to binary. Little bit more time taking, but ये direct कर सकते हैं आप. ठीक है, but just in case you have any confusion, you can follow that. Yeah, Bhanu, correct answer. Right, very correct answer. Okay, moving ahead to the next question, dear.
कर सकते हैं.
चलो next one. Okay, the Boolean expression. See, with every question I've written, what is that year and what is this mark? So this was GATE 2008 EC 2 marks question. Okay, right. But yeah, you know, looking into the current scenario, it doesn't deserve to be 2 mark. It's mostly like a 1 marker agar aata bhi aaj ki date mein. Okay, but yeah, no problem. 2016 doubly 2 marks. No. There is some error here. There is 100%. This is 1 mark. And probably previous one bhi ho sakta hai 1 mark ka ho, but this is definitely 1 mark. Okay. This is definitely 1 mark. I'll see if there is an issue. This is definitely 1 mark. So Boolean expression a plus b bar plus c plus d bar plus b plus c bar simplifies to what? Okay, simplifies to what? Yes, simplifies to what? So guys, if you just notice one calculation here, and that is what? Anything. Suppose b bar plus b. What is b bar plus b? We know that 1x plus x bar in Boolean is equal to 1. Okay, so our expression is like 1 plus something. Our expression is like 1 plus something. Okay, so 1 plus anything in Boolean is 1 and then whole complement. 1 complement is 0, answer aa gaya B. 1 complement is 0, answer is equal to the 1 complement is 0, answer is D. Everybody okay with that?
Anything in
right. Chalo, correct. Bhanu, Shanmukha, very correct answer. Yes, Ananta, correct answer. Chalo, great going ahead. Okay. Chalo, moving ahead to the next question. Have a look into this. Okay, 2002 EE2 marks question. Now it's fine. Chalo, great. Yes, guys, keep liking if you're enjoying it. Do not forget to like the session. So it's a very simple 2002 2 marks question based on the very basic Boolean circuit. Now, what is one thing that you can observe here is, okay, what is one thing you can observe here is, where is that circuit? I haven't copied here, no problem. Sorry, chalo. So let me solve it here only. So what is this? Okay, a NAND gate with shorted inputs. Okay, both the inputs to the NAND gates are common. So this represents inverter. This is the P bar and this is Q bar. Similarly, this is R bar and this is known as S bar. Okay, right. Now, yeah, further again you have a NAND gate. But what I can suggest you is to make the process little bit more simpler. What I can suggest you is this is a bubble. Okay, which will do the job of inverting. Okay, and this is also an inverter. So what you can do, effectively you can cancel out this thing because bubble will also invert and this is again the NAND gate with shorted input that is also going to invert. So effectively you please cancel it. Okay, similarly effectively you please cancel it. Okay, in the bottom side also you can cancel it. So what is the output that is obtained here? Okay, it is now AND gate. If you cancel the bubble, it is now an AND gate. So P bar Q bar. Similarly, what is this? R bar S bar. What is this? This is known as the R bar S bar. Okay. Chalo. Sharat Kumar, that depends. That decision is mostly taken by our YouTube team. Okay. It may be. Okay. But yeah, right now, let's continue. Okay. I'll look into that request, Sharat Kumar. Chaliye, this is P bar Q bar. This is R bar S bar. Okay. Now, what I will say, what is coming up here is directly P bar Q bar. And what is coming here is R bar S bar. So, what is the output Y? Okay. What is going to be the output Y? It is again a NAND gate. Okay, so P bar Q bar into R bar S bar ka whole bar. Can I say like that? A into B ka whole bar. Right, A into B ka whole bar. Right. Chalo, Bhanu says B, Vikram says D. Okay, let's check. So what is this actually? What is this actually? P bar into Q bar into R bar into S bar. Okay, whole bar. Now apply the De Morgans. Hi Akash, apply the De Morgans. It is simply P plus Q plus R plus S. It is simply P plus Q plus R plus S. So correct answer is B. Yes, Bhanu, correct answer. Okay, it is the very correct answer. Right, Vikram, just check out once. Maybe some basic calculation error you have done. Moving ahead to the next question. Okay, 2016 EC 2 marks. Yaar, ye kuch to error hua hai kya? I just have to check once. Just a moment, guys. Just wait, just a second. Chalo, by the time solve the question, and I'll just open the source file also. I'll just have the source files also open with me. Yeah. Oh, it's actually a 2 marks question. So sometimes it is surprising. Even I am not able to believe it is a 2 marks question, but yeah, actually it is 2 marks question. I was just rectifying. So I'll keep checking it from the file in case if there is any error. But yeah, this is really a 2 marks question. Bonus. Sometimes it becomes the bonus. 2016 EC 2 marks question. Okay. Chalo. So let's figure out the calculation here. So this is the AND gate with the input AB. Okay, and now this is AND gate with the input AB further multiplied by the bit C. Okay, now what is this? This is B and C, so this is BC. Okay, now there is the XOR gate. Now there is the XOR gate with AB XOR BC, and then Y is going to be further XOR with ABC. Y is going to be the further XOR with ABC. Further XOR with ABC, and here you have AB XOR BC. Now whether to solve by the formula or what is some logic you can apply? What is some logic you can apply? Good evening Nishu. What is some logic that you can apply here? Okay. Either you can go by formula, or what else you can do is formula se jaane se better, what else you can do is I'll suggest you something. So what I will do is, let us take the input bits ABC, and then what I need is AB. See, what is this output now? It is AB XOR BC XOR ABC. XOR ABC. That is what it is. XOR ABC. Okay, so there are 3 bits. Okay, it's a 3 input XOR turning out to be. So what you can very quickly do is, I want AB, I want what? I want BC, and I want ABC, right? And we know 0 0 0 0 0 1. Let's write down the 8 combinations quickly. 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1 and AB. Okay, now AB is straight away 0 0 0 0 A0 है, क्योंकि यहाँ पे this is also 0 0. Only at these two it is 1. Similarly, BC को भी workout कर सकते हैं. We know any input 0, output will be 0. Okay, so this is also 0 0. Here BC is 1, again 0 0 0, and here 1. And ABC, all 3 is 1. Only at the last we know. So this is entirely filled with zeros, and now I need to take the XOR of these 3. Okay, I need to take the XOR. What is a 3 input XOR? Okay, what is a 3 input XOR? How you can take the 3 input XOR here? Okay, the 3 input XOR output is high. The 3 input XOR output is high whenever the input string contain odd number of ones. So here there is no 1, no 1, no 1. Yeah, odd number of ones, a single 1. Okay, then 0, then 0, then 1. Odd number of ones. Here how many ones? Here there are 3 ones. That is also odd. That is also odd. That is also 1. That is also 1. Correct? Okay. So where is the Y high? Where is the Y high? Now as a function of ABC, it is high at 0 1 1 1 1 0 1 1 0 1 1 1. Correct. So where it is? It is equal to A bar BC, right, plus ABC bar plus ABC. Okay, or that is equal to A bar BC plus AB, because in the last 2 terms AB is common. C bar plus C will be 1. Okay, so I have A bar BC plus AB, out of which I take B common, and then I am left with A plus A bar C. Now if you want, you could have applied the K-map also, but very simply we are able to solve it. Okay, very simply we are able to solve it. Now it becomes B. A plus A bar C, absorption is A plus C. A plus A bar C can be written as A plus C. So B into A plus C, right? B into A plus C. Yeah, it is option number C. B into A plus C, that is option number C. We can go by formula also, but I think this is also very convenient because playing in binary bits is very easy always. Okay. Correct. Yeah, guys, that's what it's mentioned here also, na? 2016, 2008 and 2002. These 3 years. Okay, these 3 last years by IISc Bangalore. Okay. Yeah, Sharad, you can go by formula also, and if you, in case you don't get, let me know. The formula, everybody knows what is the XOR formula. Now, A XOR B is A bar B plus AB bar. That also can be tried. But you know, if you are quick in binary bits, this is more simpler. This is more convenient. Okay. Because multiplication in binary, we know what? If any bit is 0, answer will be 0. If both the bits are 1, then only the product is 1. That's what very simply I have done it. So it doesn't take much of the time. Right? Chalo guys, next. Let's not draw it, guys. We know, you know, you should know the number of NAND gates required for NOR gate. Oh, sorry, number of NAND gates required for inverter, AND gate, OR gate, XOR gate, XNOR gate. Number of 2 input NAND gates required for 2 input XOR gate. It should be how much? It should be how much? It should be how much? Quickly. It should be how much? This should be known to you. Yes, Ananta, very good. This should be 4. Okay. Now, again, if you want how it is, so you can watch my class on logic gates. I've derived there, I've explained you there. You can watch my class on the logic gates. Okay. Chalo. Yeah. So it's a 1 mark, and that is what is expected by 1 mark, at least the basic. Okay. The basic circuits should be very clear to you. Okay. Yeah, Bhanu, Nishu, correct answer. Sharad Kumar, correct answer. Moving ahead to the next one. Okay, 2002 EC 2 mark. This is a good question. See, any question based on delays and timing analysis is always good. Okay, and even today's date also you can expect some similar question because there's good questions coming up from delays and the timing waveforms. So, kya bola hai? The gates G1, G2 in the figure have propagation delay of 10 nanoseconds and 20 nanoseconds respectively. If the input Vi makes an abrupt change from logic 0 to logic 1 at time t equal to t naught. Ye dekho. At the time t equal to t naught, it makes an abrupt change, sudden change from 0 to 1. Then what is the output waveform out of the 4 options? Out of the 4 options. A good question. Okay, so kya bola hai yahan pe? The delay of G1 and G2 is 10 and 20 respectively. This is 10 nanoseconds, the XOR gate. Then there is the XOR gate having the delay of 20 nanoseconds. And this is the input waveform Vi. Okay, which makes an abrupt change from logic 0 to logic 1. Sorry. Correct, logic 0 to logic 1 at the time t equal to t naught. That is what is mentioned. At the time t equal to t naught. Correct? Hanji, chalo. Okay, so let's move ahead. Okay, let's move ahead. Now, this input first goes to the XOR gate. Acha, ideally, what is the output of the XOR gate? Ideally, what is the output of the XOR gate? Suppose this is some variable, let's say x. Suppose this is some variable, let's say x. Okay, x. So what is the value of x? It is a XOR gate, but both the inputs are shorted. It is a XOR gate, but both the inputs are shorted. No, this should not be XOR gate. Both the inputs are shorted, output 1 hoga. Nahi guys, there is a correction in the question, I think. Okay, we can check the actual file, but I'm sure there is a correction in the question. This has to be a NOR gate. Right? Please, let's take it as a NOR gate actually. Okay, please make it as a NOR gate. Okay, please make that as a NOR gate. Let me correct that here. Okay, we can definitely check the original file, but I'm sure. Okay, I'm sure I'm able to recall in my memory. Okay, let this be the NOR gate. Okay, let this be the NOR gate. Right now? Okay, now NOR gate, both the inputs common, both the inputs shorted. It behaves as inverter. It behaves as inverter. So it becomes the Vi bar. It becomes the Vi bar. If the input is Vi, output of the inverter will be Vi bar. Okay. Now look into this V0. So what is V0 now? What is V0 now? It is Vi XOR with Vi bar. Vi XOR with Vi bar. Now you think, sir, iska answer to mujhe pata hai. You might be thinking, what is Vi XOR Vi bar? I already know. So what is the sense of this question then? What is the sense of this question then? Everybody must be knowing now what is Vi XOR Vi bar. Okay, both are always different. Both are always different. So everybody knows what is the answer. Ideally 1, because whenever both the inputs of XOR, are different, output is high. So this should be ideally 1. This should be the ideally 1. Okay. Okay. This should be ideally 1. Okay? No, Bhanu, that's what a correction I'm telling. Put it as NOR gate. Put it as the NOR gate. Because agar wo XOR hoga, dekho na, XOR, both the input same. Both the input same. The output is always 1. Okay, the output will always be 1. Okay, so just look into that. Okay. No, I'm able to watch the video. Let me just again check it. No, video is fine, Bharat. Sharad Kumar, sorry. The video is moving fine. Just refresh it once. Is it buffering? Is it so? Nishu also says buffering. Guys, is the video buffering by chance? Please let me know, because for me it's running fine, absolutely fine. For me it is running absolutely fine. Let's check it out for you guys. Quickly tell me. Quickly confirm me others as well. Right. Quickly tell me. Hanji, chalo. So let me move ahead by the time. So this is ideally 1, but will it be 1? No, it will not be 1, because we have to check with the delays. What is the delay mentioned? 10 and 20 nanoseconds. So let's draw this, dear. Let us draw this. Let us start with the Vi waveform. The VI waveform is actually given to me. Okay, it makes an abrupt change from 0 to 1 at the time which is T0. Okay, so what will happen to the VI bar? Okay, we know VI bar is the complement of VI. Okay, VI bar is the complement of VI. Okay, and complement means 0 ka 1. Okay, but 1 ka 0. 0 ka 1 but 1 ka 0. But will the complement immediately happen? The complement will happen after the delay. Okay, the complement will happen after the delay of this NOR gate, which is 10 nanoseconds. So whenever the VI changes the state, VI bar will toggle. Okay, that will, it will become 1 to 0, but after a 10 nanoseconds. That means this particular time should be T0 plus 10. Is that clear, everybody? This particular time will be the T0 plus 10. This particular time will be the T0 plus 10. अब आगे जाते हैं हम लोग. What is going to be next? Okay, now we have to take the XOR of VI and VI bar. इन दोनों को XOR करना है, right? Now this is 1, this is 1, this is 0, this is 0. Okay, so 0 XOR 1, both are different. Output will be high. Okay, so now I'm calculating the output V0. Okay, 0 XOR 1, both are different. Output will start at high. But what is going to happen? ध्यान ये देना है. What is going to happen at this particular time? Okay, let me draw it. Let me draw this roughly. Okay, look into this, dear. Okay, so at the time T0, VI and VI bar at this particular time T0, VI and VI bar both look same. Okay, and for the same input, XOR output will be low. XOR output will be low. XOR output started with 1, but now it is going to be low. But will it become low immediately? It will become low after the delay of 20 nanoseconds. It will become low after the delay of 20 nanoseconds. So this is going to become low not here, not immediately, but after a delay that is equal to 20 nanoseconds. Okay, so this particular time will be T0 plus 20. Will be T0 plus 20. इसको मैं यहाँ पे अलग से लिख देता हूँ. This time is T0 plus 20. Clear? This is going to be T0 plus 20. Okay, now this becomes low. Okay, now look into that. At T0 plus 10, again the VI bar becomes 0, but VI is 1. So here again both are different. 1 and 0 means both are different, and if both are different, output will again become high. Output will again become high, but after a delay of 20 nanoseconds, because there is a delay of the XOR gate given. So T0 plus 10 plus 20. T0 plus 10 plus 20, it's going to be T0 plus 30. It will again become high. Okay, so when does the output again become high? At this time, which is equal to T0 plus 30, the output again becomes high. Okay, so look into this. What is the output waveform that is going to match? Okay, if I have to match the option, see, they are not even asking the time. हमने थोड़ा detail में solve कर लिया. The correct answer is C. They are just looking into the nature, that it was 1 for a particular time. For some particular time it becomes 0, and then again it becomes 1. That is the output we have drawn. Actually, we have drawn with the complete analysis, right? Keep this is T0, this is T0 plus 20, and then this is T0 plus 30. Okay, that is T0 plus 30. Okay, we have drawn with the even complete, more better analysis, I can say. Complete and better analysis, right, Aji? Chalo, moving ahead to the next. Chalo, next question, dear. A very simple one marker K-map question. A very, very simple one marker K-map question. Please attempt this. Chalo, come on. Let's do it up, guys, very simply and very quickly. So definitely, yeah, this is a quad, the second row, and these two ones, this also becomes the quad. Okay, this is A, यहाँ पे आ जाएगा A is 1, and then this portion belongs to B, because B is 1 here, and C is 1 at these 2 bits. I will call this as C. ठीक है जी? Now this particular chord is belonging in the A row, and this chord, see, the central 2 columns are C, that is outside C. So we will call it as C bar. So my answer is equal to what? A plus C bar. Very, very simple. A plus C bar, option number B. That's why it is 1 mark. That is why it is the 1 mark. Clear everybody? A plus C bar.
A plus C bar.
A plus C bar, option is B. Okay, next question ready for you. Gate 16 EC 2 marks, 5 variable map it is. 5 variable map it is. Do it up quickly, guys. Please do it up. Yeah, let's do it up quickly. Following is the K-map of a Boolean function of 5 variables P, Q, R, S and X. The minimum SOP expression for the function is? The minimum SOP expression for the function is how much? The minimum SOP expression for the function is how much? Let's look into it, guys. Okay, so let's analyze this. 5 variable K-map we know is split into 2 4 variable K-maps. Okay, which are just the images of each other. Okay, one of the 4 variable K-map is for the MSB low, one of the 4 variable K-map is for the MSB high. Okay, so this is x equal to 0. So whatever answer comes up here, we'll multiply with x bar. So let us first form the groups here. Okay, let us first form the groups here. This is RS. These two bits R is high. Okay, the central 2 bits you can see S is high. So let me write down S here for the central 2 rows. PQ is here. Okay, so last 2 combinations P is high. Center 2 combination Q is high. So यहाँ लिख देंगे Q. Similarly, let me just copy this same because it is the image. Okay, sorry, this is RS correct and ऊपर है P and the central 2 columns are Q. And now I will give you the grouping. 1 1 1 1. First and last columns are adjacent. So this is a quad. Okay, this is a quad. In the second one, okay, again we have just one quad because the first and last row are also adjacent in the K-map. Okay, all right. So many of you already coming up with the answer, that is B. Let us match it up quickly. So what about this quad? Very clearly, this is in S and center 2 column is Q. So that is outside Q, right? S Q bar. What about this quad? Okay, now look into it. Is it in R? No, half in R. Dekho, center 2 rows is S. It is outside S bar. And this is completely within Q. So it is Q. Completely within Q. So what is my answer then? Whatever is the first answer, that is corresponding to MSB 0, x equal to 0. So we multiply by x bar. You know, the code is whenever a variable is 0, okay, we take its complement in the Boolean function expression. Okay, right. So this is x bar multiplied by SQ bar, and next one is going to be x multiplied by S bar Q. Multiplied by S bar Q. Now let's match the option. Okay, x bar SQ bar, x bar SQ bar. Okay, ये दिख रहा है plus x S bar Q, x S bar Q. Yeah, B is the very correct answer and that's what many of you are giving. B is the very correct answer. B is the very correct answer. चलते हैं next question की तरफ. Okay, if the input x3, x2, x1, x0, okay, to the ROM in the figure are 8421 BCD numbers. This is a BCD. The input here is BCD and then you have a BCD to the decimal decoder. Okay, and then you have some connections as we usually represent in the case of ROM. Okay, what is the output? Y3, Y2, Y1, Y0. Okay, is it gray code? Okay, whether the final output is gray code or 2421 BCD numbers or XS3 code number, yeah, none of them. Yeah, none of them. It's a decent question. 2002 easy 2 marks. Okay, back, but it is a good decent question based on ROM. So हमें क्या करना है? I'll just show you a simple analysis here. Okay, to relate x3, x2, x1, x0, y3, y2, y1, y0. See, no need to make the table for d0 to d9. Unnecessary in the MCQ option. Let's not make it unnecessarily lengthy. Let's not make it unnecessarily lengthy. Just allow me 1 minute. Just allow me 1 minute. Please solve it up by the time. Hello. Yeah, I think video is fine. There isn't any issue with the video. You can just refresh it once. Okay, chalo, let's move ahead. Yeah, so what I was suggesting you is directly make the relation between x3, x2, x1, x0 to y3, y2, y1, y0. And now what is the input? It is a BCD input, and you know the regular 8421 BCD code. You know what is the 8421 BCD code? The regular binary combination 0000, 0001, 0010, 0011, 0100, 0101, 0110, 0111, 1000 and 1001. That is the last binary combination we usually take, because it is a BCD, binary coded decimal. Okay, so we code the decimal number in binary and the decimal digits are only 0 to 9. Okay, now corresponding to 000, now it is a BCD to decimal decoder. Okay, it will give you the correct decimal value for the corresponding BCD code given. So 0000 is corresponding to D0. It is corresponding to D0. Now D0 is not connected to any of the ROM outputs. D0, there is no switch, there is no cross connection mentioned here. We know how to read the outputs of ROM. Okay, there is no connection mentioned. This is what is a connection representation in ROM. If there is no connection here, that means y3, y2, y1, y0 is not connected, any of them. Okay, and then there is going to be no current flow in that case, and that means the y0, any of the output will be 0. Any of the output will be 0. Okay, so what are the outputs? 0, 0, 0, 0. Similarly, 0, 0, 0, 1, we have the D1 output, and D1 output is connected to Y0. Okay, so Y0 will be high. Okay, 0, 0, 0, 1. Okay, next. Now similarly, keep looking next. Okay, keep looking next. Okay, let me write down. This is D0, D1, D2, D3, D4, D5, D6, D7, D8, D9. Right. So 0, 0, 1, 0. 1, 0 means 2. Okay, which one? Only Y1. Only make the Y1 high. Next dekh lenge guys. Next is going to be 0, 0, 1, 1. That is D3. And at D3, we have Y1, Y0 again. Okay. So that is 0, 0, 1, 1. So till now it is just replicating, but let us see the further also for confirmation. So what is next? 0, 1, 0, 0. 0, 1, 0, 0 means D4. Okay. D4 means Y2 is high. D4 means Y2 is high. Okay. Ye bhi ho gaya 0, 1, 0, 0. Till now also it is same. Next is 0, 1, 0, 1. 0, 1, 0, 1 is 5. Okay, that is also replicating. Okay, that is also replicating. Y2 and Y0. Okay, Y2 and Y0. So 0, 1, 0, 1. 0, 1, 0, 1. That's it. Okay, now next 0, 1, 1, 0. 0, 1, 1, 0 means D6, and now Y3, Y2 will be high. Y3, Y2 will be high. Y3, Y2 will be high. Yahan pe disturb ho gaya. Till now it was replicating, but now it is disturbed. 1, 1, 0, 0. Okay, next. Okay, 0, 1, 1, 1 means D7 output. D7 is connected to Y3, Y2, Y0. Y3, Y2, Y0. Okay, next is what? Okay, 1, 0, 0. 1, 0, 0 means D8. It is connected to first 3, Y2, Y3, Y2, Y1. Okay, Y3, Y2, Y1. Previous one kya tha? D7. D7 was 1, 1, 0, 1. Acha, ye kuch gadbad ho gaya. This was 0, 1. Okay. Now next, last 1, 0, 0, 1, D9. D9 is connected to all, so that should be 1, 1, 1, 1. Now definitely it is not the same 8421, and it is not gray code also. Okay, one of the option is gray code. It is definitely not gray code. It is definitely not gray code, because gray code yahi pe samajh mein aayega na. Gray code is 0, 0, 0, 1, 1, 1 and 1, 0. At least the 2-bit gray codes you know na. That should match. Rest also you know it is a reflected code, but 2-bit ka to yaad hi hoga. 0, 0, 0, 1, 1, 1 and 1, 0. So definitely it is not gray code. It is not XS3 also. It is not XS3 also. Okay, because XS3 means BCD plus 3. 0, 0, 0, 0 plus 3 will be 0, 0, 1, 1. It is not XS3 also. Okay, 2421 check karenge. Is it 2421? Right. Is it 2421? Right. What is the meaning of the weighted code 2421? Yeah, any weighted code. Okay, when you multiply the particular binary bit with any of the weights given here, okay, multiply 2 into 0, 4 into 0, 2 into 0, 1 into 0, and when you add this, the answer should be the corresponding decimal number, right? So if I take it as 2421, it is correct 0. Okay, 0001. Yeah, this is 1. 0010. 1 किससे multiply होगा? 2 से. So total is 2. 1 and 1. 2 plus 1. ऊपर क्या है? ऊपर add the corresponding weight. So that is 2 plus 1, 3. Okay, this is corresponding to 4. So yeah, this is 4. Okay, then these two means 4 plus 1. That is 5. That is 5. 1100. 1100. 11 means 2 plus 4. 6. Correct चल रहा है. Okay, 1101. 2 plus 4 plus 1. 2 plus 4 plus 1. 7. 1110. तो 2 plus 4 plus 2. That is 8. 2 plus 4 plus 2 कर लेंगे 8. All 1. तो 2 plus 4 plus 2 plus 1. And that is nothing but 9. That is nothing but 9. So as per the 2421 code system, it is completely matching. Okay. So this is what is a 242 code 1 of the decimal number. So the output is 2421 code. 2421 code. That's what I told you. It's a good question. It is a good question, dear. ठीक है, चलेंगे next question की तरफ. Okay. चलेंगे next question की तरफ, and if you are enjoying it, do not forget to put your attendance. Okay, and attendance means just hit the like button. Okay, to express your attendance, to express your attentiveness, and to express your love and motivation towards the session. Alright guys, so let's get moving ahead. Next question, here it is. Okay, 2016 1 mark, very simple multiplexer based question. Okay, very simple multiplexer based question. Okay, yeah, already Python has been started on YouTube, and the complete course details will be available to you soon, Sadhna. Okay, but definitely Python classes is there for you, so you can watch that live. Daily 7 PM Python classes are going on. चलिए 2016 1 mark, very simple question. इसमें तो कुछ है ही नहीं डिस्कस करने का. So what is going to be the output F? Okay, select line is connected with B. So select line 0, that is B bar. Output will be I naught. And what is I naught? A bar. So B bar, A bar, plus select line 1, I'll write it as B, then I1, that is A, right? So output is nothing but A bar, B bar, plus AB, and that is A XOR B. It is the XOR gate, nothing but the XOR gate. Okay, and the XOR means it is the output of XOR. They have written in the form of option number D. Yeah, correct answer, Ananta, Sai, Kiran, Bhanu, Prakash. Very correct answer. It is the A XOR B, and we know XOR is the complement of XOR, तो ऐसा भी लिख सकते हैं इसको, ठीक है? तो option number D is the very correct option. We have the next question rolling out for you. For the circuit shown in the following figure, I0 to I3 are the inputs to the 4:1 multiplexer. R is the MSB and S are the control bits. The output Z can be represented by. The output Z can be represented by. ठीक है? So again, a basic multiplexer, but slight calculation will be there. So it's a 2 marks EC 2008 question. Okay, चलिए ले लेते हैं इसको. Okay, ले लेते हैं इसको. So let's write down the Z here. Again, select lines are RS. So 0 0. R bar S bar. Okay, then I naught. And what is I naught? What is I naught? It is the OR gate output P plus Q bar. Okay, let me slightly darken it. This is Q bar. Hope you are able to see. Okay, this is the Q bar. थोड़ा सा slide हो गया यहाँ पे, but yeah, I have corrected it. Okay, so I naught. I naught means P plus Q bar. Okay, then select line 0 1. That is R bar S. Okay, multiplied by P. Then 1 0 R S bar. Okay, 1 0 R S bar into I2. That is P into Q. That is P into Q. Plus select line 1 1. That is RS multiplied by P. Multiplied by P. Okay. Okay. Okay, we just now need to first of all simplify and see if we want the help of K-map or not. Okay, so arranging in order P R bar S bar plus Q bar R bar S bar. Okay, then you have P arranging in sequence P R bar S. Okay, plus P Q R S bar plus P R S plus P R S. Okay, so let us see what are the terms you can simplify here at least. If some of the terms can be directly simplified, or we can feed this in the K-map if required. देखो, इन दोनों से तो what you can do is, okay, see R bar S bar is common, so that was anyways common. R bar, okay, so let me take first of all this terms. So P R bar, okay, S bar plus S is 1. Okay, then Q bar R bar S bar. Okay, from the last two terms, what is common? I think P and R can be taken as common. P and R को कॉमन लिया तो you have QS बार प्लस S. ओके, तो यहां से भी एक टर्म सिंपल होगा. सो आई हैव PR बार प्लस Q बार R बार S बार, ओके, प्लस PR plus PR, S plus S bar Q is S plus Q. S plus S bar Q, again absorption will apply. S plus S bar Q is S plus Q. ठीक है. So now let's look into some of the options if we are able to match it up. Any of the term Q bar, R bar, S bar आएगा. Okay, or it may be simplified also. And then PRS plus, okay, P यहाँ से भी common आ जाएगा. Now if I want to combine these two terms ना, okay, so P will come common. R plus R bar S. Yeah, R bar plus RS will be R bar plus S. R bar plus RS will be R bar plus S. Again, absorption is applied. Q bar R bar S bar plus P RQ plus P RQ. Okay. So further to simplify it, I think we have to go to K-map only because none of the option is directly matching. Q bar R bar S bar जरूर आएगा. Other than that, I think it's a semi-minimized form. मुझे ऐसा फीलिंग आ रही है कि दे हैव गिवन सम सेमी मिनिमाइज्ड फॉर्म. ओके, यहाँ से P कॉमन लिया तो नो, दिस इज नॉट करेक्ट. Q बार R बार S बार तो बच ही रहा है. यहाँ से P कॉमन लिया तो देन आई हैव Q प्लस S. इसको पूरा ही सॉल्व करते हैं ना. ओके, दिस टू P कॉमन लिया, R बार प्लस R S प्लस Q, तो इट्स डायरेक्टली गोइंग टू बी R बार प्लस S प्लस Q. R पूरा ही एब्जॉर्ब हो गया ना. ओके, प्लस Q बार R बार S बार. ओके, सो P R बार प्लस P S प्लस Q S प्लस P Q. P S P Q. No, I think it is a semi-minimized form, right? It is a semi-minimized form only. No, P plus Q plus PQ plus PS. No, PQ plus PS. PR bar absorb नहीं हो रहा है ना. That also we have to check, Bhanu. That also we have to check. Q bar R bar S bar. चलो, we can feed this in the K-map and we can complete it up. Okay, little bit K-map पे जाएंगे, but yeah, you just complete it up. Okay. Please do complete and match the option because options are like semi-minimized. That's what is the feeling I'm getting. Okay, so yeah, that is a basic calculation. Let's not waste much of the time in calculation. Let's move ahead. Okay, देखते last में if we have time because there are many more questions to come up. Okay guys, let me know you can complete the calculation ना, comfortable. Yeah, K-map में डाल दीजिए, आ जाएगा. ठीक है, we could have fed it in the K-map. But let's move ahead. Yeah, let's move ahead right now because calculation part you can deal with the K-map. Okay. We already saw 2 or 3 K-map question also. Now let's come to the next question because many more important questions हैं जिसका idea आपको लेना है. A 4:1 multiplexer is to be used for generating the output carry of a full adder. Okay, A and B are the bits to be added while C is the carry input and C in is the carry input and C out is the carry output. A and B are used as the select bit with A being the more significant bit. Okay, which one of the following statement correctly describe the choice of the signals to be connected to I0, I1, I2, I3 so that the output is C out? Now, what is the full adder carry output? What is the full adder carry output? That's what it is used to generating the carry output of a full adder. So what is the carry output of a full adder? It is given by summation of the minterms 3, 5, 6, 7. That's what you must be aware about so that you solve this question. The carry output is given by summation of the minterms 3, 5, 6, 7. Now what is available at the select lines is AB. Okay, and then we have the 4 options on the different slide. So what is available on the select lines is AB. Okay, right. So what will go to the input lines? Okay, what will go to the input lines? It is going to be C. If AB are at the select lines, the C variable will be used at the data line, at the input line. ठीक है, अच्छा. So what I have to first of all make is the implementation table. What I have to first of all make is the implementation table. We know that the shortcut to solve this is the implementation table, and implementation table will contain the 4 columns I0, I1, I2, I3. I0, I1, I2, I3 according to the 4 input bits, and C bar and C. C bar and C. Okay, the two rows corresponding to C bar and C, because select line पे A B है तो data line पे C जाएगा. Now, okay, what minterms to be written at C bar, what minterms to be written at C? Okay, so C. देखो ABC 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1. We know these are all the 8 combinations. So guys, where is the C 0? At every alternate term, that is at every even term, it is equal to 0. So what are the minterms that should be written here? What are the minterms that should be written here? 0 2 4 6. What are the minterms corresponding to C? So when does C write? When do you write C? When C is equal to 1. So C is equal to 1 at the other alternate set, that is 1 3 5 7 at the odd number cases. 1 3 5 7. Now next step is what? Next step is highlighting the minterms which is to be included in the function. So 3 5 6 7, that is the carry output of full adder. Now this you must directly know because you have studied full adders. Okay, so bubble, just circle this one, 3 and then 5 and then 6 and then 7 and write down the answer here. Okay, write down the answer here. So in the first column, no circle, that is 0. In the second column, circle is corresponding to C. In the third also, circle is corresponding to C. In the fourth, it is corresponding to both. Both means C plus C bar dono aayega. C plus C bar is 1. Whenever both circle, output is 1. So the sequence is 0 CC1. 0 CC1, yeah, correct Ananta and Bhanu Prakash. Right, 0 CC1. 0 CC1. Okay, so option is 0 CC1, option number A. 0 C in 1. Correct? That's what it is. Option number A is the very correct answer. Option number A is the very, very correct answer. That's what it is. Hanji, ठीक है? Next question here. For the circuit shown in the figure, the delays of the NOR gate, multiplexers and inverters are 2 nanoseconds, 1.5 nanoseconds and 1 nanoseconds respectively. Okay, if all the inputs P, Q, R, S and T are applied at the same time instant, what is the maximum propagation delay of the circuit? What is the maximum propagation delay of the circuit? What is the maximum propagation delay of the circuit? Okay, now why maximum propagation delay? Well, what can be maximum or minimum? Because there are multiplexers and which input of the multiplexer is active, that depends on the select line. And the problem is one of them has the select line as T, another one has the select line as T bar. Okay, has the T bar. Okay, so if I just look into this, let's take the first case. If the select line, that is T, is 0. Okay, if the T is 0, so what is the data path? Okay, let's draw the critical path here. Okay, let's draw the critical path. So agar T ka value 0 hai, agar T ka value 0 hai, so for the first multiplexer, if select line is 0, I0 will be selected, and for the second multiplexer, okay, the select line is 1 because T bar will go, select line is 1, so I1 will be selected. So what is the data path? It is something like this. Okay, the multiplexer and then this one and the final output. So let us see in this particular path what are the delays involved. Okay, what are the delays given? The delays of NOR, multiplexer and inverters are 2, 1.5 and 2. Okay, the first NOR gate 2 nanosecond, then multiplexer 1.5 nanosecond. This NOR gate delay not required because that is not in the data path. Then again multiplexer 1.5 nanosecond. Okay, so total कितना हो गया? 1.5 plus 1.5 plus 2, total हो गया 5 nanoseconds to reach to the output. Total will be 5 nanoseconds. Clear everybody? For the first case, but I don't know T is 0, T may be 1 also. So let's look into the case number 2 when T is equal to 1. If T is equal to 1, the first multiplexer select input is 1, but for the second one select input becomes 0. Okay, select input 1 means this inverter path will be there. Then output of the multiplexer. यहाँ पे तो I1 था, but here the select line is 0, so here I0 will be selected. So I0 input is coming from the NOR gate output. So NOR gate वाला path आएगा. Then multiplexer output will be coming up. Delay of the inverter is 1 nanosecond. delay of the multiplexer is 1.5 nanosecond, NOR gate delay 2 nanosecond, again multiplexer delay will be counted 1.5 nanosecond, तो total हो गया 1 plus 1.5, okay, plus 1.5 plus 2, total 6 nanoseconds, total 6 nanoseconds. Okay, so in both the cases delay is different, in both the cases delay is different. Okay, so what is the worst case delay? Okay, what is the delay? Answer is the maximum of what? 5 or 6. There are two possibilities. So what is the worst case or maximum propagation delay of the circuit? It is 6 nanosecond for the case t equal to 1. Okay, ठीक है? Yes, RDK correct answer, Ananta correct answer. 6 nanoseconds is the answer. So numerical answer type, good question on the delay analysis, maximum propagation delay of the circuit. It is 6 nanosecond based on the T input. It could be 5 or 6. So maximum is 6. Yeah, Bhanu Prakash. Correct answer. Moving ahead to the next question. Here it is. 2008 EEE 2 marks. A simple question based on decoder. Okay, a 3-line to 8-line decoder with active low outputs is used to implement a 3-variable Boolean function as shown in the figure. What is the simplified form of the Boolean function implemented in the product of sum form? Simplified form of the Boolean function implemented in the product of sum form. Tell me. Implemented in the product of sum form. Check karte hain. Implemented in the product of sum form. Okay. So, yeah, what are the decoder outputs selected? Now see, it is a decoder with inverted output, but there is a OR gate with inverted input. That's basically nothing but a NAND gate. But what you can do is you can actually cancel these inverters to make your problem simple. Okay, because inverter in series, they don't do anything. They cancel each other's. Okay, so these two can also be cancelled. In dono ko cancel kiya, in dono ko cancel kiya. And now what could be my final answer is, now which input? This is I0. This is D1, sorry, 001. Okay, 001. Okay, A0, A1, A2 are connected to ZYX actually. Is that sequence correct? ZYX. Okay, ZYX. हाँ ठीक है, correct है. And this is A0. Of course, A0, A1, A2 में A2 is the MSB. So 001. That is Z bar, Y bar. या इसको K-map से simplify कर ले. We are looking in the POS form actually. Sorry. We are looking in the simplified POS form. चलो तो ऐसा नहीं करते हैं. What I will do is, okay, what are the minterms coming up here? It is the minterm 1 and 3 and 5 and 6. It is 1 and 3 and 5 and 6. It is 1 and 3 and 5 and 6. To get it in the simplified POS form, we know what do we do? F bar kitna hoga? So F bar will contain the minterms 0, 2, 4 and 6. It will actually contain the minterms 0, 2, 4 and 6. It will actually contain the minterms that is 0, 2, 4 and 6. And let me draw the K-map corresponding to it because I want the simplified expression. From the K-map, we will get the SOP form, na? Okay, so what is the MSB? MSB A2, that is X, and then this is YZ. Okay, A2, A1, A0, X, YZ. This is X, YZ. We know this will be the region for X. This is going to be Y, this is going to be Z in the 3-variable map. And now let me make the entries. Okay, so 0, 1, 2, 3, 4, 5, 6, 7. These are the two entries, and now this becomes a pair. First and last column adjacent to this is also a pair. Okay, so is pair, this is the pair belonging in Y and outside Z, YZ bar, and this is the pair that is within X. Okay, within X and outside Z, so Z bar. Okay, so what is the F bar here, dear? Please see, the F bar is equal to XZ bar plus YZ bar. Okay, XZ bar plus YZ bar, और Z bar को common ले लिया तो X plus Y. X plus Y. Simplified form कुछ miss हुआ है क्या? Okay, it has 1, 3, 5 and 6. Perfect. So I have 0 and 2 and अच्छा 4 and 6. 0 मैं miss कर दिया. That's what. Okay. Just a second. I missed writing 0. I have to rewrite it. Yeah, I missed writing 0. So this is 0. 0, 1, 2, 3, 4, 5, 6 and 7. Okay. So यार ये तो और मैच नहीं होगा. Right, is there some issue coming up? 1, 3, 5 and 6. Perfect. Okay. And then F bar is 0. And then it is going to be very minimized form only. Now, let me check the actual question, I think. Just a second here. कोई सा भी फॉर्म ले ले, आंसर इससे मैच नहीं होगा अनंता. Just a second, let me match with the actual question paper. Where is it? And this is from the combinational circuits. This is EE or EC? This is EE question. Just a second, है ना, थोड़ा सा इसका मैं actual निकालता हूँ अगर. Okay, 1356 correct है, 1356 ही है. That is in the form of XYZ. नहीं, then it's नहीं, canonical नहीं ना, RDK canonical नहीं, simplified form बोला है. Maybe the simplified form should not be mentioned. Let me see whether they have mentioned simplified form. हाँ, उन्हें simplified भी बोला है. Okay, simplified बोला है उन्हें. Oh हाँ, ये 7 आएगा ना, that's what. Yeah, so there is the point. Okay, 1356 to 0, 2, 4 and 7. Oh, I think while writing I made a small mistake. So now, okay, perfect. 0, 1, 2, 3, 4, 5, 6 and 7. Perfect, it is perfect, perfect, perfect. Now we can make this is clearly a pair. This cannot be paired with anything because this has no adjacency, and first and last columns are adjacent. ये हो गया pair. Now this is belonging to outside y, outside z. So y bar, z bar. Okay, this is directly the minterm 7 x, y, z. It cannot be paired with anything, and this particular is above x and outside z, x bar, z bar. तो यहाँ पे लिख देंगे. So I have the f bar. What is the f bar? Okay, that is x bar, z bar plus y bar, z bar plus x, y, z. So what is going to be f? Now you apply De Morgan. So it is going to be x plus z. Then next term is y plus z, and then again plus becomes into x, y, z will be written as x bar plus y bar plus z bar. This is the De Morgan's applied in one single step, and now our answer will be matched. Okay, that is x plus z, y plus z, x bar plus y plus z bar, option number A. So yeah, there was some writing error, I think, because of which we just got little misguided. Okay, it is 0247. वो गलती से 6 copy हो गया था. Clear everybody now? Okay, clear everybody. So correct answer is option number A. A fundamental question. The correct answer is option number A. Let us move ahead to the next question on your screen. Here it is. Identify the circuit below. Gate EC 2016 2 marks. A decent question again. Identify the circuit below, whether it is binary to gray, binary to XS3, gray to binary, XS3 to binary. Okay. Okay. Zero to liya hai na, we took another 0 actually. That also you can do. You can do the pairing of 0. That's also another method. Okay. वो relevant नहीं है. The problem was we just had a typo error in that list. Right, Ananta? Chalo, done hai ji. Yeah, let's start this one now. Okay, 3 to 8 decoder and 8 to 3 encoder. What I will do is, okay, let me form a table connecting the input directly x2, x1, x0, जैसे वो ROM वाला question किया था, and directly writing down the output y2, y1, y0, y2, y1, y0, and let's take, okay, all the input combinations 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1, 1, 1, 1. Okay. Now, there is something very important in this question, and what is that I will tell you. Now we know that this is a regular decoder. So at 0, 0, 0, OP0 will be high. OP0 is connected to IP0, and whenever IP0 is high, the output of the encoder is also 0, 0, 0. Similarly, 0, 0, 1 pe OP0 connected to IP1. Okay, so IP1 means 0, 0, 1. 1 means 0, 0, 1. Okay, next. At 0, 1, 0, we have OP2, but OP2 is connected to IP3. OP2 is connected to IP3, and IP3 is high. 3 means 0, 1, 1. So यहाँ पे आएगा 0, 1, 1. Next, input is 0, 1, 1. 0, 1, 1 means OP3 is high, but OP3 is connected to IP2. Okay, so 0 1 0. IP2, 2 means 0 1 0. So till now it looks like a gray code. It is looking like gray code. 0 0 0 1 1 1 and 1 0. It looks like gray code. Next chalte hain hum. Okay, next 1 0 0. 1 0 0 means, okay, yeah, this is a typo error. Of course, this has to be OP4. Usme to koi doubt nahi hai. Okay, that has to be a typo error only. So this is OP4. Now OP4 is connected to IP6. OP4 dear is here connected to the IP6. Okay, IP6 means 6 means 110. Then 5 is connected to 7. 7 is 111. Okay, 6 connected to 4, 100. Okay, 7 connected to 5, 101. Okay, so now is it finally the gray code? Is it finally the gray code? Okay, is it finally the gray code? Tell me. If it was gray code, we know gray code, reflecting code. अगर इसको मैंने half में divide किया, if I divide this into half, okay, MSB will complement 0 ka 1, but look into this. The upper half should be totally the mirror image of the bottom half. Yeah, vice versa I can say. So this is mirror image 1 0 1 1. But if this is 0 1, यहाँ पे 0 1 आना चाहिए. Then only it is the gray code. Okay, then only it is the gray code. Okay, so it is not binary to gray. Binary to gray tab hota when last two connections are actually 6. IP4 going to 7 and 7 going to 6 would make it as the binary to gray code converter. Then it becomes a real good conceptual question. But unfortunately for this question, none of the option is going to match. None of the option is going to match. Okay? Neither it is gray to binary also. Okay, ये gray to binary भी नहीं होगा. ये gray to binary भी नहीं होगा. Right, because even if it is gray to binary, what I'm telling, okay, this was 4 should correspond to 7 and 5 should correspond to 6. That is what I'm, sorry, last two में मैंने problem बोला था ना. Okay, so yeah, 6 should go to 101. Yeah, 6 should have gone to 5 and 7 should have gone to 4. Right. Okay, so even if I make, even if you look into the reverse calculation also, even if it was gray to binary, for 111 it should be 101. Yahan to same hai, but for this 111 it should be 101. Okay, but that is not the case. That is not the case. Right? For 111 we need 100. So it is wrong. It is wrong. So actually guys, this question, I will tell you the reality. This question, none of the option will actually match. Neither it is gray to binary nor it is binary to gray. None of the option will match. And then what happened? I think some typo error was done by IISC also. They could not maybe rectify it. So this question was challenged by the students. Okay, and none of the questions, none of the options were matching, and that is why it became a bonus question. That is why it became a bonus question. Okay, marks to all were allotted. MTA means marks to all. It was a bonus question and every student, okay, were given the marks. Okay, every student was given the marks. Moving ahead to the next question, dear. Okay, here it is. Yeah, moving ahead to the next question here. GATE 2002 double E1 mark question. GATE 2002 double E1 mark question. Okay, let's have a look into it. Very simple question based on a single flip-flop. It's a D flip-flop. Okay, now we know that for a D flip-flop, the output, the next state, see this is the output Q, this is Q bar, this is Q. The next state, okay, Q plus is given by the input D. But what is D? D is connected with Q bar. Okay, it is Q bar. The next state is Q bar. Q plus equal to Q bar. No, Bhanu, that's what. In the previous question, actually they desired to design the question as binary to gray only. Okay, but unfortunately there was a typo error. देखो ना, आप पिछले question में वापस जाओगे, so it would be a binary to gray code only. It would be a binary to gray code only. ठीक है, only if last two connections were properly managed. ठीक है, that means this 6. Okay, we want 101 there, so it should be connected here. Okay, and 7 should have been connected here. Okay, so I think they made a typo error. Otherwise, the intent of the question was to design binary to gray code only using this cascaded decoder and encoder structure. ठीक है भानु, चलिए, right. Have a look into this question now. Have a look into this question. 2002 double E 1 mark question. Yeah, we were solving it. So Q plus equal to Q bar, right? At every clock edge, positive edge triggered hai, at every clock edge, okay, the next state will be toggle of whatever is the current state. Okay, so frequency of the clock signal applied to the rising edge triggered D flip-flop, positive edge triggered D flip-flop basically, is 10 kilohertz, clock frequency 10 kilohertz. What is the frequency of the signal available at Q? What is the frequency of the signal available at Q? So I will draw the clock waveform, and with that I will draw the Q waveform. Suppose this is the clock. And we know that the device is positive edge triggered. Okay, and let's assume Q initially 0, no harm in that. Let us assume the Q initially 0. Okay, and if it is initially 0, at the positive edge of the clock it will toggle, 0 will become 1. Then it will again toggle, but at the next edge. At the next edge it will again toggle. Toggle means now it becomes 0. At the next edge it will again toggle, becomes 1. At the next edge it again toggles, it becomes 0. So this is also periodic waveform. Okay, periodic waveform. Now what is this? This is known as one time period of the clock. The time between repetition. This is the time period of the clock. So what is the time period of the output waveform? What is the time period of the output waveform? Definitely this is one T clock and this is one more T clock. This is one more time period of the clock cycle. So we have two time periods of the clock. So this is 2T clock. This is known as the 2T clock, right dear? This one is known as the 2T clock. Okay, so what is the time period of the Q waveform? It is known as the 2T clock. So what is the frequency? Frequency is reciprocal of time period, 1 upon 2T clock, and 1 upon T clock is frequency of clock. So this is half of the frequency of the clock given, and the frequency of the clock given was 10 kilohertz. The answer is 5K. 5 kilohertz. The correct answer is option number D, 5 kilohertz. Very simple. Correct answer is D, 5 kilohertz. The very correct answer is D, that is the 5 kilohertz. Right dear? 5 kilohertz. Next, the current state of two JK flip-flop system is 0, 0. Okay, of the two JK flip-flop system, a very simple question on counter. This next state is to be required. Assume that the clock rise time is much smaller than the delay of the JK flip-flop. The next state of the system is, okay, so rise time and delay mentioned bhi nahi hai, so both we have to just neglect only. We have to just calculate the next state of the device. Okay, so what is going to be the next state of the device? Okay, if the current, we don't have to actually calculate the complete cycle also. Okay, let us write this QA QB, which is initially 0, 0. Okay, this is 0, this is 0, so its complement will be 1. Okay, because its complement is 1, both JK inputs are 1. And what about this JK? Acha, ye kuch missing hai, ye J missing hai. So I have to check this question. This is doubly 2 marks. Chalo, isko bhi dekhna padega. Double E sequential circuits mein, just I have to check the source file, 2016. Okay. Both of them, yeah, this is also connected here. Both are connected to 5 volt. Both are connected to the 5 volt. Okay? Both are connected to the 5 volt here. Okay? Now that means 5 volt means logic level 1. So these two are 1, 1. So both J and K equal to 1. J and K equal to 1 is what calculation of the JK flip-flop. Whenever both the inputs are 1, it will represent a toggle state. That means the device will toggle. Okay, so the next state QA will become 1, and here also both the inputs are 1. So the device will toggle. 0 tha, next state will be 1. So entire next state QA QB will be 1, 1. Simple. The entire next state will be 1, 1. It's a synchronous counter only. The next state will be 1, 1. Option number C. The next state 1, 1. Very simple for 2 marks actually, isn't it? Very simple for 2 marks. Isn't it dear? It's very simple actually for 2 marks. Done hai ji? Very, very simple for 2 marks. Chalte hain next question ki taraf. Okay. For each of the positive edge triggered JK flip-flop used in the following figure, the propagation delay is delta T. Which of the following waveform correctly represents the output at Q1? Which of the following waveform correctly represents the output at Q1? Okay, it's also a 2 marks 2008 EC question, a conceptual question you can say. Okay, so which of the following waveform represents it correctly? This is the this is the clock waveform. For each of the positive edge triggered JK flip-flop used in the following figure, propagation delay is delta t. For each of them, propagation delay is delta t. It is the case of what? If you look into this, it is nothing but a ripple counter. Okay, because the Q output of one goes to the clock input of the next. So this is the case of ripple counter, right? And whenever we have the ripple counter, okay, what is the total time required? What is the worst case delay till the MSB? What is the worst case delay till the MSB? What is the worst case delay till the MSB? Tell me. What is the worst case delay till the MSB? Okay, the total propagation delay is equal to the n t flip flop. Okay, n times the flip flop delay. Okay, what is n? It is a 2 stage. And what is every flip flop delay? It is 2 delta t. Okay, एक तो ये observation हो गया 2 delta t. ठीक है. Also, it is a 2 flip flop combination. Okay, it is a mod 4 case because 2 flip flops, there is no reset circuit. So it's a regular 2 flip flop circuit. So it will have total 4 states. It is a mod 4 counter. It is a mod 4 counter. Okay, and we are trying to trace what? We are trying to trace the waveform at Q1. Q1 is MSB. Okay, because clock जहाँ पे apply ripple counter में where is the clock applied? Clock is applied to the LSB. So definitely Q1 की बात कर रहे हैं तो Q1 means the MSB. Q1 means the MSB. Q1 बोले तो MSB. So what is the frequency at MSB? What is the frequency at MSB? Okay. FQ1 means FMSB and the frequency is MSB is the clock frequency divided by the mod number. Clock frequency divided by mod number. Okay, so what is the time period of the Q1 waveform? Time period is the reciprocal of frequency. So that should be 4 times the time period of the clock. एक calculation ये हो गया. If the frequency of Q1 is 1/4 of the clock frequency, time period of the Q1 is 4 times the time period of the clock. It is 4 times the time period of the clock. Okay, now based on this, we can just match the option. Number 1, the time period of the clock is T. Okay, so time period of the output waveform should be 4t. Time period of the output waveform should be 4t. Okay, and the output will be seen at, see, when is the clock edge coming up? The clock first positive edge is at T1. T1. Okay, so output, which is at Q1, should be coming up after 2 delta t. Should be coming up after the delay of 2 delta t. T1 plus 2 delta t. So this is wrong. T1 plus 2 delta t. Option number B is correct. ऑप्शन नंबर बी इज करेक्ट. ठीक है, तो यहाँ पे ये 2t रॉन्ग है, ये 40 करेक्ट है, बट डेल्टा टी इज रॉन्ग. द टोटल इज 2 डेल्टा टी. करेक्ट. This is how conceptually and logically you can solve the question without minimum calculation and maximum observation. With minimal calculation, I can say that it's a 2008, but it's a decent good question. Okay, based on the understanding of frequency of MSB and also the delay involved in the ripple counter. Done है जी. Next question की तरफ चलते हैं. For the circuit shown in the figure, D has a transition from 0 to 1 after clock changes from 1 to 0. D has a transition from 0 to 1 after clock changes from 1 to 0. Assume that the gate delay is to be negligible. Which of the following statement is true? 2008 EC 2 marks question. 2008 EC 2 marks question. करते हैं इसको. Okay, which of the following statement is true? Okay, D has a transition from 0 to 1 after clock changes from 1 to 0. Okay, तो D has a transition from 1 to 0. ठीक है, D has the transition from 1 to 0. ठीक है, अब देखो अगर D पहले 0 था या what we can do is, yeah, this is the waveform given to me. Okay, so what is coming up here? This is D, so this is D bar, and then this is going to the NOR gate with clock. Okay, this is also going to NOR gate, but D is going with clock. Okay, so what comes up here is D plus NOR gate है तो D plus clock का whole bar, and this is D bar plus clock का whole bar, and then you have the basic NOR gate latch. Okay, this is the basic NOR gate latch. Okay, this is like the R input and this is like the S input. Okay, this is the NOR gate latch. You can recall your concepts from the basic latch. This is the NOR gate latch, this is the S input and this is the R input. ठीक है, अब देखो initially the clock is 1. देखो first case हम ऐसा देखेंगे, when the clock is equal to 1 but D is equal to 0, clock is 1, D equal to 0. ठीक है, अब देखना अगर क्लॉक 1 है, ओके, 1 प्लस एनीथिंग इज 1, तो आउटपुट विल बी 0, तो R 0 हो जाएगा, R will be 0. What about S? Okay, D is 0, so D bar will be 1, and clock is anyways 1, so 1 plus anything is what? 1, complement 0, so S will be 0, R will be 0. Okay, ये first stage होगा. Okay, second stage में what is happening? Clock becomes 0, but D is still 0. Okay, clock equal to 0, D equal to 0 for a certain period of time. Okay, मैं इसको यहाँ पे लिख देता हूँ. Okay, let me expand this waveform. This is the clock waveform. Sorry, clock goes from 1 to 0. Okay, and D goes from 0 to 1 after certain time. Okay, this is clock, this is T. Okay, and I am calling this one, okay, as the first region, then the second region and the third region. Okay, the second region में both clock and D are equal to 0 for a certain period of time. ठीक है, अब अगर clock and D both are 0, 0 is 0 plus 0 is 0, complement will be 1, तो R का value 1 आ जाएगा. But what will happen to S? देखो, D is 0, D bar will be 1, 1 plus anything is 1, complement करके 0, S equal to 0, R equal to 1. Okay, third stage पे आ जाएंगे. तो what is happening in the third stage? Clock is 0, but now D makes a transition from 1. Now D makes the transition to 1. Okay, तो क्या हो जाएगा? Right, because D makes the transition to 1. Okay, 1 plus anything is 1, complement करके 0, तो R is 0. Okay, but यहाँ पे देखेंगे तो okay, D is 1, तो D bar is 0, तो 0 plus 0, 0, whole complement is 1, तो S equal to 1. Okay, S equal to 1. Now, S equal to 0, R equal to 1. S equal to 0, R equal to 1, reset combination. Okay, so Q plus will be 0, output will become 0. S equal to 1, R equal to 0, it is a set state combination, so Q plus will be 1. Okay, solving it by the SR latch methodology. S equal to 0, R equal to 0. So what is the initial output? Okay, what is the initial output? अच्छा, initial output नहीं given है. Okay, initial output नहीं given है. So whatever is the initial output, we don't know, but Q plus will be Q, because whenever both the inputs SR are 0, 0, there is same state condition. This is known as the same state condition, this is the reset state condition, this is the set state condition. Okay, now what is happening is when clock makes the transition, सबसे पहले clock का transition हुआ, have a look into it. Okay, there is the clock making the transition, and next D is making the transition. So when clock makes the transition from 1 to 0, okay, at that time Q will become 0, the device will reset. ऑप्शन देखेंगे. ओके, तो Q goes to 0 at the clock transition. ये तो ठीक है, Q goes to 0 at the clock transition. But what happens next? At the D transition, it becomes 1. At the D transition, okay, does it stay at 0? No. Okay, but it goes to 1 when D goes to 1. यही देखा ना? When D goes to 1, that is going to go to 1. So very correct answer is D, dear. The very correct answer is option number D. Okay, so some questions, as I told you, in an IISc paper will be conceptual, tricky. Okay, it's not difficult. It is not difficult, but it is testing your basic understanding of the concepts and the latch. Okay, so I'll not say difficult, but I'll not say very direct also. Okay, although it's 2008, but a decent, worthy question. All right, dear, let's move ahead to the next then. Let us move ahead to the next case. Again a 2016, although 1 mark, but a good question here again. Okay, assume that all the distal gates in the circuit shown in the figure are ideal. The resistor R is 10 kilo ohm and the supply voltage is 5 volt. The D flip-flops D1, D2, D3, D4, D5 are initialized with the logic value 0, 1, 0, 1, 0 respectively. The clock has a 30% duty cycle. What is the average power dissipated in this resistor? Let us first derive its cycle, and then we'll talk about the average power dissipated in the resistor, which is of 10 kilo ohm. Let us look into this circuit. The D inputs are initialized with 0, 1, 0, 1, 0. Okay, 0, 1, 0, 1, 0. They are initialized with this value. Okay, that is 0, 1, 0, 1, 0. D1, D2, D3, D4 and D5, and this is nothing but a ring counter case. Can I say it is a ring counter case? Okay, because the output of every D flip-flop goes to the next, and the final D output, okay, direct Q output comes to the, let us say, serial input. Okay, so it is nothing but a ring counter case. Okay, so if the initial state is 0, 1, 0, 1, 0, correct? Okay, so whatever is the D5, okay, that will go to what is known as the serial input. Okay, so that will be 0, and then right shift 0, 1, 0, 1, and ye 0 yahan pe aa jayega. So just rotate it in the ring counter manner, nothing. 0, 0, 1, 0, the 0, 0, 1, 0, and 1 comes to the MSB. Okay, then 1, 0, 0, 1, and then 0 comes up here. Then 0, 1, 0, 0, 0, 1, 0, 0, and 1 comes up here. Next 1, 0, 1, 0, 1, 0, 1, 0, and 0 comes up here. But if you note 0, 1, 0, 1, 0 वापस आ गया. If you note 0, 1, 0, 1, 0 वापस आ गया. Okay, so the state repeats. So the state repeats. Okay, so this is one cycle. Okay, one cycle up to this. Okay, don't count the repetition. It is up to this, I can say. Clear? Okay, now let us say this is the X output. Okay, which is the output of OR gate coming up from, this is the D3. So suppose isko bol diya, oh sorry, I should not take it as D3. The D flip-flops are initialized with the logic values. Okay, so ये तो actually इनके Q outputs का computation में कर रहा हूँ. So let's write it actually the Q outputs of the D flip-flop. Let us say this is Q1, Q2, Q3, Q4, Q5, and Q3 plus Q5 will make the X. Q3 plus Q5 will make the X. Okay, ये तो हो गया repetition. Okay, so what is the X here? Let me write down the X here only. Okay, and what is going to be the value of X? ध्यान देना. It is going to be the OR. It is going to be the OR of Q3 and Q5. Okay, Q3 and Q5 का OR. So 0 plus 0 is 0, 1 plus 1 is 1, 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, 0, 1, 0, 1, 1, and then again it will repeat. 0 plus 0 is 0. It will repeat again. Clear, everybody? Okay, so can I draw the X waveform? Dear, can I draw the X waveform? Can I draw the X waveform? Okay, it is 0, then 1, then 0, then double 1, 1, again 1, and then again 0, but this is the repeated wala 0. This is the repeated wala 0. This is known as one full cycle. This is known as one cycle. Okay, it cycles through 0, 1, 0, 1, 1. Okay, this is the one cycle. Clear? This is the one cycle. And one cycle is equal to how many clock periods? Okay, there are 5 states, 1, 2, 3, 4, 5. Okay, so there are 5 clock cycles involved here. Okay, so one cycle, and in one cycle, the time period of this waveform is equal to 5 times the clock time period. Okay, 5 times the clock time period. Okay, the 5 times the clock time period. Chalo. Now what do we need? Do we need the value of the time period? Do we need the value of the time period? What is the average power dissipated in this resistor which is of 10 kilo ohm? Okay, so what is the normalized average power? Dear, what is the normalized average power? If you take R equal to 1 unit resistance, we calculate the normalized average power. We calculate the normalized average power, and that normalized average power is given by, the shortcut is, थोड़ा signals का concept apply करेंगे, energy in one time period, okay, divided by the value of the time period, because it is a periodic waveform, na? It's a good question, dear, है ना? Energy in one time period divided by the time period. Energy in one time period divided by the time period. And now this logic level 1 actually corresponds to 5 volt. Corresponds to 5 volt. Okay, so this makes a rectangular pulse. What is the energy of a rectangular pulse? A square into D. How much is this duration? Okay, this is equal to T clock. And how much is this duration? This is total 2 T clock. यहाँ पे 2 T clock involved है. So out of the 5 cycles, 3 times it is 1 and 2 times it is 0. Okay, so what is the energy of a rectangular waveform? Amplitude square into duration. Amplitude square, that is 5 square into duration T clock, plus Okay, logic level 0. The signal 0, that means it has no energy content. Okay, again the signal is 1, that is amplitude 5 volt. So again amplitude square into duration, and then the next duration is 2t clock divided by the total time period of the periodic waveform. The total time period is 5t clock, and that is why the t clock is not required. Okay, so it is nothing but एक बार 5 cancel हो जाएगा, t clock भी cancel हो जाएगा, so 5 plus 10, that is equal to 15. That is the average power, but that is for r equal to 1. That is for the r equal to 1. Okay, अब मैं यहाँ पे final answer लिख देता हूँ. For the r is equal to the 10 kilo ohm. Okay, what is the average power? That was the normalized average power. It is given by 15 divided by 10k, so it will become 1.5, and kilo ऊपर जाएगा तो बन जाएगा milli. Okay, तो 1.5 milliwatt. Let's see how the options. It's a NAT question. Milliwatt में चाहिए. 1.5 is my final answer, dear. 1.5 is my final answer. A very good question. A very good question, combining the concept of average power, the concept that you can solve from signals. Okay, and with the general ring counter analysis. ठीक है जी, with the general ring counter analysis. Right, any confusion, anytime you can let me know, but these are good questions. Okay, these are the good questions. Moving ahead to the next, dear. Here it is. Again a good question based on counter. Again a very good. That was 1 mark. ऐसा हो जाता है. See, some questions were simple for 2 mark also. Some questions they become very tricky for 1 mark also. Okay. Chalo guys, for the circuit shown in the figure, the delay of the bubble NAND gate is 2 nanoseconds. Okay, and that of the counter is assumed to be 0. Hypothetical situation. ऐसा होगा नहीं कि the delay of counter is 0 but delay of a NAND gate is 2 nanoseconds. But assume if that is the case. Okay, the delay of the bubble NAND gate is 2 and delay of the counter is assumed to be 0. If the clock frequency is 1 gigahertz, then the counter behaves as what? The counter behaves as what? Okay, it's again a very good question. Okay, it's again a very good question. So let us write down the state Q2, Q1, Q0. It's a regular counter. The first of all, let us try to write down all the states of the counter, but there will be a certain point where the reset will come. Okay, it's an active low reset because bubble or bar दोनों लिखा हुआ है. So definitely it's an active low reset case. It is active low reset. Okay, and suppose the input is X here. Okay, suppose the reset input is X. Okay. Right, and what is the input here? This is Q2, this is Q1, but this is Q0 bar. Okay, Q0 का bar. Okay, उसका NAND लेना पड़ेगा हमें. So let's write down 0, 0, 0, then 0, 0, 1, 0, 1, 0, etc. Now, because it is an active low reset, we know what is the concept of active low. It is going to reset the counter. It is going to reset the counter if it receives the low signal here. Okay, if it receives the low signal here. So when will be X equal to low? When will be X equal to 0? X is the output of NAND gate. Output of NAND gate is 0 if and only if all the inputs are high. If and only if all the inputs are high. If and only if all the inputs are. What are the inputs of the NAND gate? ये देखोगे. One is Q2. All the inputs are high. Okay, Q2 1 होना चाहिए. Next is Q1 should also be 1. And next is, this is Q0 bar. ध्यान देना, it is Q0 bar. This should also be 1. This should also be 1. That means what I can say is, okay, what should be the Q2, Q1, Q0? It should be 1, 1 and 0. 1, 1 and 0. Okay, तो यहाँ तक चलेंगे 0, 0, 0. ठीक है, चलो. तो I have to actually, I should write it in the next slide. I should actually write this in the next slide to have the crystal clear discussion. Q2, Q1, Q0. It starts from 0, 0, 0. Then we have 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0. Sorry. 1, 0, 1, 1, 1, 0, 1, 1, 0. यहाँ पे stop कर जाते हैं ना. 1, 1, 0. Everybody, 1, 1, 0. Now we know what happens at 1, 1, 0. At 1, 1, 0, X will become equal to 0. Okay, X will become 0. Okay, counter will reset. Counter will reset. But will the X become 0 immediately? Will the X become 0 immediately? देखो, there is a delay of the NAND gate and that is to be taken in the picture, 2 nanoseconds. Okay, the delay of the NAND gate is 2 nanoseconds. So X will be equal to 0, okay, but not immediately. after the delay, that is 2 nanosecond, so counter will reset. Counter will also reset after 2 nanosecond because there is no delay of the counter, dear. There is no delay of the counter. So counter will also reset after 2 nanosecond. X will be 0 after 2 nanosecond. So clock frequency कितना है? Clock frequency is 1 gigahertz. Okay, so what is the time period of the clock? Time period is 1 upon clock frequency, and 1 upon 1 gigahertz. 1 gigahertz is 1 into 10 power 9. So 10 power minus 9. So clock frequency, clock time period कितना हो गया? 1 nanosecond. Okay. Yes, very good, Bhanu. The clock time period is 1 nanosecond. That means each and every state, okay, is coming after 1 nanosecond, 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 after 1 nanosecond. ठीक है सर, counter तो reset होगा, but for the counter to reset, it needs 2 nanoseconds because of the NAND gate delay. Because of the NAND gate delay. That means 2 nanosecond तो बाद में आएगा, but after 1 more nanosecond, okay, the next state of the counter will automatically come 1 1 1. After 1 more nanosecond, the next state 0 0 0 will automatically come. Okay. Okay, so that means if you wait for 2 nanoseconds more, anyways the 0 0 0 will come on its own. So all the states will come. See, if there was no delay of the NAND gate, तो immediately this will, because counter का भी delay नहीं है, NAND gate का भी delay नहीं है. So as soon as X becomes 0, the counter will reset. So immediately this will be 0 0 0, and then it would be a mod 1 2 3 4 5 6. 1 2 3. Then it will be a mod 6. Ananta, it will be mod 6 if there was no delay of the NAND gate. Okay, but because of the NAND gate delay, okay, the rest two states are also counted, and it is mod 8. It is mod 8. Okay, so it is a mod 8 counter. Extremely good question. कहाँ चला गया? It is a very good question. Just a second, I think it has stuck to a slide. It will be rectified automatically. Got this? Yes, delay plays a very vital role. So what you're able to observe in the IISc Bangalore pattern is that, okay, whether it is through combinational circuits or logic gates or through even counters, reset के questions वो जरूर put कर रहे हैं. Okay, so mod 8, option number D. If there was no delay, मैं ये लिख भी देता हूं आप लोग के लिए separately, right? If there was no delay, then it is mod 6 100%. Then it is going to be the mod 6 counter 100%. ठीक है? Then it is going to be the mod 6 counter 100%. चलते हैं next question की तरफ, dear. Guys, time passing away. See, I am taking a non-stop session. Are you guys tired? Time passing away, students dropping. Are you guys tired so quickly? Are you guys tired so quickly? I am not tired. Okay, I have not even had my dinner by this time, but I am not tired, guys. Are you guys tired? Are you guys tired? Quickly tell me. Next question. Next, again, a very good question coming up. Tell me, yaar, thak gaye kya aap log? If you are tired, let me know. I'll stop. But then only these many questions discussed. Abhi there are some more questions coming up. Tell me. Yes, guys. Tell me, यार. एकदम ऐसे थक जाओगे तो काम नहीं चलेगा ना. just chalo. So if everyone is okay, let's continue then. Okay, if you guys are okay, let us continue. Okay ji, chalo, yeah. So the state transition diagram for a finite state machine with the states ABC and binary inputs X, Y, Z is as shown in the figure. Which one of the following statement is correct? Again, a very good question. Which one of the following statement is correct? Transitions from state A are ambiguously defined. Ambiguously means little bit confusing. Yeah, unclear. Okay, transitions from state B are ambiguously defined. या state C, या all of the transitions are defined unambiguously. सब कुछ correct है, कोई confusion नहीं है, तो option D करेंगे. So let's analyze this state diagram. It's a basic state diagram analysis question. Okay, so what I will do is for all the values of the inputs X, Y, Z. X, Y, Z are the inputs, and inputs can take 8 possible states. We all know the inputs can take 8 possible states because there are the 3 inputs. There are the 3 inputs X, Y, Z. Okay, X, Y, Z. Okay, and let me write down the current state. Okay, which could be A, or which could be B, or which could be C. ध्यान देना अब यहाँ पे. Okay. So what I can tell you here is, now let me write down all 8 possibilities. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Okay. 1, 1, 1. Okay. ठीक है. नहीं, it is all good. Nothing is cut, Bhanu. Chalo, so guys, now please analyze this question with me. Look into the current state A. ध्यान देना. From the current state A, if the input is 0, 0, 0, next state will be B. So I will keep writing the next state here, which will be B. Okay. For the current state A, yeah, let me read the state diagram also. यहाँ देखेंगे. Dear, whenever Y is 1. अच्छा हाँ, this left part is cut, sorry. Okay, yeah, you're correct, Bhanu. So Y equal to 1. This is Y equal to 1. You can note now. Okay, and this is X equal to 0, Z equal to 1. ये है X0, Z1. Okay, now everything is clear. ठीक है, now everything is clear. So please note, whenever Y equal to 1, next state will be A only. That means there is no change of the state. Whenever Y is 1, तो next state will be A only. तो यहाँ पे A, here also A. ठीक है. Now next, Now whenever input x0 z1, ये वाला ट्रांजिशन देखेंगे, whenever input x0 z1, next state will be a, whatever may be y, but x0 और z1 ढूंढना है, right? x0 z1, x0 z1, okay, that's it. These are the two cases. So this is already a, यहाँ पे भी a fill करना है. So next state will be a. Okay, now what is the next transition? Have a look into this. Okay, और इसमें क्या लिखा है? x1 and y0. What is written here is x1 y0. Whenever x1 and y0, x1 y0, these two. Okay, the next state will be c. The next state will be c. Okay, next state will be c. Everything else, everything is done. This transition, this transition, this transition, this, all outgoing transition. मतलब all state changes I have defined here. So यहाँ पे there is no ambiguity. For every value of the input, I have a clear transition mentioned. I have a clear transition mentioned. Next आ जाते हैं. Okay, if the current state is b, if the current state is b, then what is going to happen? Then what is going to happen? So again देखो, if b is equal to 1, if b is equal to 1, okay, ये रहा. Sorry, if y equal to 1, I'm sorry. If y equal to 1, the next state remains to be b. The next state remains to be b only. The next state remains to be b if y equal to 1. ठीक है. Now, what is the next outgoing transition? इसको देखेंगे. What is this y0 z0? y0 z0. So if y0 z0 कहाँ है? y0 z0, these two. The next state will be a. It is going towards a. तो यहाँ at these two places please write down a and a. अच्छा, next क्या है? This is done. This is done. What is next? From the b, this is next. If y0 and z1, if y0 and z1, if y0 and z1, these two. Okay, the next state will be c. The next state will be c. तो इन दोनों पे c लिखना है. इन दोनों पे लिखना है c. So again, for all different values of the input, my next state transition is clearly defined. Do I have any confusion? No. Everything is clearly defined. Everything is clearly defined. I don't have any confusion. ठीक है, तो next I will check with the state c. Okay, so next I'll check with the state c. State c पे आ जाते हैं. Look into this. Whenever z is 0, the next state will remain to be c. Whenever z is 0, that means at these alternate cases, next state will remain to be c only. So c, 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 c at these alternates. ठीक है. Next क्या होगा? Next क्या होगा? Next क्या होगा? ये देख लेंगे. Whenever x1 and z1, please note this. Whenever x1 and z1, whenever x and z are 1, 1. Okay. x1, z1, x1, z1. x1, z1, x1, z1. The next state will be a. The next state will be a. तो इन दोनों पे a लिखेंगे. I will write this a. I will write this as a. Okay, these two are a. Clear? Next क्या होगा? What is left? So this is also done. This transition is done. Okay, what else is the transition left? ये y1 and z1. y1 and z1 next state will be b. Okay, y and z11. y and z11. Next state will be. Next state will be. Next state will be. Okay, b. Okay, ये 1 1 पे यहाँ b, ये 1 1 पे यहाँ b. अब प्रॉब्लम ये है, at this place the next state should be b, but already a next state is written here. So one of the transition says कि c होना चाहिए. One of the transition is telling you that it should be b. यहाँ पे आया mistake. यहाँ पे आया confusion dear. This is the confusion. Okay, whether it should be a or b. Whether it should be a or b. That is the ambiguity. That is the ambiguity. Whether it should be a or b. And one more ambiguity is there. Ki when the input is 0, 0, 1, what is the next state? It is not defined. Okay. The next state corresponding to the state C is not defined. So that is why I can say that the transitions from the state C are ambiguously defined. Confusion. Not clear. Very, very unclear. Ki if the input is 1, 1, 1, what should be the next state? That is a doubt, A or B. And if the input is 0, 0, 1, what is the next state? That is not at all defined. Okay. So corresponding to the state C, the transitions are unclear. So I will go with the option number C. I will go with the option number C. I will go with the option number C. Right? Again, a very good question. Analysis. See guys, this is more like, if this is not a very difficult question of state diagram. Even if you know what are state diagrams, बस आपको read करना आता है, I can say that it is a very good question, but purely an aptitude based question. You have to analyze a state diagram. Okay, you have to analyze and state diagram and see which of the transitions are not clear. It's mostly, you can say, a very logical type of question. Although I'll call it as a very good question. Okay, I'll tell you because I remember in 2016, okay, most of the topper type of students faced it, attempted it. Most of the topper type students attempted it, correct? Next question ki taraf chalte hain. All right, guys. Yeah. So this workshop is, I think, already done. But yeah, again, if you have not attempted the workshop, you can go to the BYJU'S exam prep app, because this workshop has already happened just today, taken by your favorite Abhinav Negi sir. Okay, just at 7:30 p.m. today, and he has given 5 important tips for 100% execution of the gate preparation strategy. Also, guys, okay, get a chance to win up to 90% scholarship by appearing in the National Scholarship Test. Sunday, 27th August from 9 a.m. onwards. Okay, take a next step towards your success in GATE. Register now again on the BYJU'S exam prep app. Okay. Next question, dear. Okay. Fundamental question of the ADC. The number of comparators required in a 3-bit, okay, in a 3-bit comparator type ADC. Tell me. Number of comparators required. How many? 2 power n minus 1. How many comparators required? 2 power n minus 1. Comparator, basically flash type comparators are used, one by one, lots of comparators are used in the flash type. Okay, so it is 2 raised to the power 3 minus 1, and that is 7. That is 7. Yes, Gate and Bhanu Prakash, correct. It is C. 2002, simple, 1 mark. Okay, next question here. All right. Okay, so this is a linked question. Up to 2013, there were linked questions also in the GATE. In the following circuit, the comparator output is logic 1. This is a good question. The comparator output is logic 1 if V1 greater than V2. Okay, comparator output is logic 1 if V1 greater than V2. Okay, ye V1, ye V2 hona chahiye. I think that is missing here, but no problem. And is logic 0 otherwise. The DA conversion is done as per the relation VDAC. Some formula is given. I will analyze that formula also. Okay, B3 is MSB, B0 is LSB. Okay, and B3, B2, B1, B0 are the counter outputs. Okay, the counter starts from the clear state. The counter starts from the clear state. Okay, what is the stable reading of the LED display? And what is the magnitude of the error between VDAC and VIN at the steady state? Okay, these are 2 linked questions here. These are 2 linked questions here. Okay, so let us analyze this. Let us analyze this. Okay, this is V1 actually. This input is V1. This is V2. Okay, this is V2. Acha, first of all, let me analyze this VDAC formula. Okay, first of all, let me analyze this VDAC formula. Okay, what is this VDAC formula? The conversion formula that is given by summation of, okay, summation of, यहाँ अगर मैं open कर दूँ, okay, from n equal to 3, let me start from the MSB, so 2 raised to the power 3 minus 1. What will be 3 minus 1? 2. So let me write it as 2 power 2 actually. 2 power 2 into B3, 2 power 1 into B2, 2 power 0 into B1, 2 power minus 1 into B0. Or I can say that the output of the DAC is given by 4B3 plus 2B1, sorry, 2B2 plus 2 power 0, that is 1, plus B1 plus half B0. Okay, now what is the VLSB? Okay, that is known as resolution. VLSB, or also known as the resolution, or also known as the step size. Okay, when I just take 1 step ahead, that is the LSB. Okay, so LSB means only B0 is high. LSB means only B0 is high, so that is going to be half. Okay, that is 0.5 volt. Okay, so what is the resolution of the DAC? It is half volt, 0.5. Okay, so in terms of analog output, it will be moving in terms of 0.5, 0.5, 0.5 step. It will be moving in terms of 0.5, 0.5, 0.5 steps. Okay, तो अब एक simple सा table बना के इसको solve करेंगे, right? What you have to do is, okay, we have to compare with the analog input Vi, okay, and what is the V2? V2 means the VDAC. What is this V2? It is the output of the DAC. Counter starts from clear state, that was clearly mentioned. Okay, the counter starts from the clear state. Okay, so let us write down the counter output. Okay, that is suppose Q3, Q2, Q1, Q0. Okay, based on the counter output, I will give you the VDAC. Okay, okay, based on the VDAC. Okay, let me also write down the V input, which is fixed at 6.2 volt. Okay, and then based on that, I will decide whether the clock is active or not. whether the clock is active or not. अब देखो ध्यान देना. Okay. Okay. Right. So counter output. Initial output, the counter starts from 0, 0, 0, 0. Corresponding to digital input 0, analog output is 0. Okay. Now this is the clock. Okay. And this is the external clock. This is the main clock going to the counter. The problem is, the point is, ये जो DAC का output है, ये जो DAC का output है, ये हमें देखना है whether it is 1 or 0. Sorry, this is the comparator output. This is known as the comparator output. Okay, so let me also write down what is the comparator output. Comparator output, and then I will write down the clock status. Hope this is visible. Okay, then I will write down the comparator. Now 0, 0, 0, 1. Okay, so when I move one step ahead, that is why I calculated the step size. Na? When I move one step ahead, the DAC output will move by 0.5. V in fixed है. अब देखो, whenever comparator output क्या बोला? Comparator output will be 1 if V1 greater than V2. That means if Vi, okay, yeah, V input is greater than the VDAC. Is greater than the VDAC. Okay, so till the Vin greater than the VDAC, comparator output 1. And if the comparator output is 1, it is going to be multiplied by clock and it is going to reach the main clock. So yes, clock is available. Yes, clock is available. Okay, so I'll just show the status of the clock, whether it is available or not by right and wrong. Next state 0010, DAC output will be 1. Yes, 6.2 hai. So again, 6.2 greater than 1. So yes, clock is available. Comparator output is high. Comparator output is high. Okay, next will be 0010. Okay, sorry, that is already done. Next will be 0100. देखो, etc. Okay, change कहाँ पे होगा? Okay, change कहाँ पे होगा? Okay, so if I just keep moving, see, corresponding to 2 I get 1, corresponding to 4 I will get 2 because step size is half, na? So let us reach 1100. Corresponding to 12, the DAC output will be 6 because step size is half. So corresponding to 12, I will reach 12 into half, that is 6 volts. Still, the 6 is less than 6.2, or I can say V in greater than VTAC. Comparator output is still high. Clock is still available. Okay? But as soon as the next state comes 1101, the DAC output will move by 0.5 step ahead. That will be 6.5 and the Vin is 6.2, and now the Vin is less than VDAC, so comparator output will be low and the clock will not reach the counter, and if the clock doesn't reach the counter will stop. Okay, if the clock doesn't reach the counter will stop, and I can say that this is the saturated output of the counter. This is known as the saturated output of the counter. This is known as what? The saturated output of the counter. Clear, everybody? Saturated output of the counter. Okay, so now what was the first question? The stable reading of the LED display. Okay, the LED display. So there is a binary to BCD conversion, and that is going to convert into 2-digit LED display. So what is the saturated output? मैंने बोला saturated counter output is 1101, that is corresponding to 13 in decimal. Okay, that is corresponding to 13 in decimal. So when you convert this to decimal, what will be the LED display? 13. What will be the LED display? 13. Okay, and then at the steady state, what is the magnitude of the error between VDAC and Vin? Very clearly seen in front of you. What is the error between VDAC and Vin? 0.3 volts. Okay, ये तो just bonus है. Just one table you have to make, and that only is giving you counter output 1101. That is corresponding to the decimal number 13. So that will be the reading of the display. That will be the reading of the LED display. And also by the same table, at the steady state, the difference between Vin and VDAC is 0.3. So it's just one concept, one calculation, giving you 2 questions here. Linked question है. अब linked question आता नहीं है, but just I am telling you. Okay, so for the first one it is D, next one it is B. That's it. Moving ahead to the next question. Okay, 2 8-bit ADCs. Okay, 2 8-bit ADCs. one of single slope integrating type and other one successive approximation type, take TA and TB times to convert 5-volt analog input signal to equivalent digital output. If the input analog signal is reduced to 2.5, that is half. Okay, क्या किया? Input to be converted is made half. Because earlier it was 5 volt. Okay, then approximate type taken by 2 ADCs. So what are the ADCs? One is integrating type and another one is SAR type. Okay, for the SAR type, does it depend on the analog input? For the SAR type, okay, it doesn't depend on the analog input. If it was TB, it will remain to be TB. But for integrating type, if the input is halved, the conversion time is also half. That is what, see, it's a 1-mark question. So what are the fundamentals you learn in ADC that you have to apply? You don't have to derive here. So it's going to be TA by 2 and TB. TA by 2 and TB. Okay. It's not like this. It is TA whole divide by 2 and TB. Not A by 2. TA whole divide by 2. Okay. And TB. Okay. Even in the counter type, the conversion time depends on the analog input to be converted. Okay. But in SAR, successive approximation time, it remains to be same. Correct hai ji? So correct answer is B. TA by 2 and then TB. Okay. Next one. Okay, a temperature in the range of -40 to 55 degrees is to be measured with the resolution of 0.1 degree Celsius. The minimum number of ADC bits required to get a matching dynamic range of the temperature sensor. 2016 EE 1-mark question. Okay, in the range. So what is the total range? -40 to 55. So the total range is actually 95 degrees Celsius. And it is to be measured with the resolution of 0.1. Okay. What is the resolution of step size? The resolution bole to kya? Resolution bole to step size. And how much is the step size? 0.1 degree. So what is the number of steps that you require? Okay, if you are moving in step of 0.1, 0.1, 0.1 and to cover up a range of 95 degree, okay, number of steps required is definitely 95 upon 0.1, that is 950. So how many bit design is required? Okay, if it is n bits, okay, then I can say that the number of steps, the maximum number of steps is 2 raised to the power n. For an n-bit design, it is 2 raised to the power n, and definitely this 2 raised to the power n must be definitely greater than or equal to 950. Okay. If there are some extra possible steps, we can discard it. Okay, so solving it, what is the value of n? Okay, what is the value of n? What is the minimum value of n? Okay, so 2 power 9 will not match. 2 power 10. 2 power 9 is 5 into 2 power 10. Log walk से solve करने का need नहीं है. Directly take 2 power 10. 2 power 10, 1024 is greater than 950. So minimum steps is 10. Why it is minimum? Even if you take 11 bits, 2 power 11 is also greater ना. ठीक है, तो एक लिया तो दूसरा तो satisfy हो ही जाएगा. ठीक है. It is option number B. Okay. What is the next question, dear? Yeah, this is again a good question here. A 2-bit, doubly 2 marks question. Good question, but solution very simple actually. Okay, a 2-bit flash analog to digital converter is given below. The input is in the range 0 to V, 0 less than V less than 3. So this input is between 0 to 3, as you're able to see. That is why the total VCC is 3 here. The expression of the LSB of the output B0. Expression for the LSB of the output, that is B0, as a Boolean function of x2, x1, x0. अच्छा, अब आप ये देखो, okay, let's take this circuit. अच्छा, it is not copied here, no problem. If you look into this, okay, you can solve it by the voltage divider. Okay, and what is this? See, actually it is not required, but just I'm solving it for you. Okay, this is 100 upon 1 plus 2 plus 1 plus 1. Okay, 600. So it is 1/6 of 3. Okay, then it is going to be 2 plus 1. This is 3 by 6, that is half of 3. 2 plus 2 plus 1. Okay, that is going to be 5 by 6 of the total voltage 3, and this is ultimately 3. Okay, so by applying the voltage divider at different steps, we know what is the voltage that is going to be the input to the comparators. ठीक है. अब point ये आता है अब पॉइंट ये आता है कि we know that at some point of time all comparator outputs will be low. At some point of time all the comparator outputs will be low, and here if all the comparator, when the input is very low, when the V in is very low, okay, all the V plus will be high, all comparator outputs will be low, X2, X1, X0 will be low, and then you have a encoder. What is this digital circuit? The only thing that you must be aware about is, okay, what is the digital circuit used in this flash type analog to digital converter? Can you please name it? Can you please name it? Can you please name it? What is the digital circuit that you should use in this flash type ADC? Comparators followed by what? Please, can you name it? If you name it, then only you are able to solve the question simply. Otherwise, you'll be wasting a lot of time. So, can you please name it? The output of the comparators go to what in a flash type ADC? ये तो पढ़ा होगा तो ही solve होगा. Go to what? Come on, anybody, recall. Anybody, quickly, तेजी से. Yes, Ravi Teja. Yes. This digital circuit is nothing but a priority encoder. It is a priority encoder. Okay, it is a priority encoder. So now let me write down the outputs B1 and B0. Okay, now because all the inputs are 0, it is 0, 0, 0. The encoder output is 0, 0. Okay, but now what will happen? Pay attention that whenever the V in rises, next क्या होगा? V in will rise so that V in will rise, V in थोड़ा थोड़ा बढ़ेगा, and then what is going to happen? There will come a time when this will become greater than 3 by 6. Okay, this will become greater than 3 by 6. ठीक है, greater than 3 by 6. So this is going to change. Okay, this is going to change. Okay, so next possibility that is going to come is, okay, 0, 0, 1. ये reverse कर दिया है क्या यहाँ पे? V in is to the minus terminal. नहीं यार, there is some error. I think, just let me check on for a moment. Again, this shouldn't be the case. Just a second, है ना? I believe 2016. Let me just rectify it for the sake of clarity with the original question. Just a moment, dear. W only, na? अरे हाँ, this is it. Correct. Yeah, there's a typo error here. 100%. That's what I'm telling, na? Because V in should go to the plus terminal. Okay, that is what. V in should always go to the plus terminal. Okay, there is a typo error here. Okay, and this will be minus, this will be minus, this will be minus. Okay, have that correction. Okay, have that correction. So that is what I was continuing now. मैंने official question paper check कर लिया. So whenever V in becomes greater than 3 by 6, that is 0.5. Okay, so what is going to happen? X0 will become high. Whenever V plus greater than V minus, comparator, V plus greater than V minus, output of the comparator high. So X0 will become high. X0 will become high. Rest 2 are 0. 0, 0, 1 means decimal 1. So encoder output is 0, 1. After a certain point of time, see, don't write down the Vn inputs, but you know, Vn, suppose if even more, it is more than this. How much? 9 by 6. It is more than 1.6. Okay, 1.5. So it is greater than 3 by 6 also. That means both these comparator output will be high. Both these comparator output will be high. Okay, and then finally after some time, Vin will rise high so that it even becomes greater than 15 by 6, and then all the three comparator outputs will be high. Okay, that is why we use a priority encoder here, because whenever multiple inputs of the encoder is high, it will give the output corresponding to the highest priority input, and highest priority is corresponding to the MSB always. So here 0 1 1, this is higher priority, x1 is higher priority, the output will be 0 1. Okay, now it is triple 1, sorry, x1 is highest priority. Okay, so it will give corresponding to x1. Okay, it will give corresponding to the x1, that is the higher priority na, if I am not wrong. 0 1 1, it will give corresponding to 0, it will give 1 0 as the output. Okay, it will give the output as 1 0, and then finally 1 1 1, the highest priority is x2, and it will give the output corresponding to the highest priority input, and that is 1 1. That is 1 1, right? That is 1 1. ये हो गया B0 B1. Just a second. 0 0 0. Next was 0 0 1, 0 1 1 and 1 1 1. अच्छा, x3 यहाँ पे mentioned ही नहीं है, ठीक है, no problem, no role of the x3 also. Okay, but yeah, accordingly I have written the value. So x2 को ही वो ले लेते हैं हम highest, and highest is 1 1 according to x1 1. ठीक है, fine है. Okay, so what is the output expression B0? Okay, what is the expression for B0? Okay, what is the expression for the B0? It is high at 0 0 1, that is x2 bar x1 bar x0 plus 1 1 1, that is x2 x1 x0. Okay, so x0 you can take common, rest it is a bar b bar plus ab, that is x2 XNOR with x1, or I can write this as x0 into x2 XOR with x1 का whole complement, because options are in the XOR format. Correct है? Yes, so correct answer is then A, x0 x2 XOR x1 whole complement, option number A. Correct, option number A, perfectly correct. ठीक है? So you're able to see that questions based on ADCs, whether it is flash type or even successive approximation type, or some basics of ADC DAC like resolution and step size and all, they are all important. Okay, and mostly what you have seen. Okay, so I have covered number system questions, logic gates question, Boolean algebra question, K-maps question, combinational circuit question, sequential circuit question, ADC and DAC question, almost all of them covered. Okay, and time is 11:10. So yeah, I think it's more than 2 hours for the session. So now we can stop here. Okay, we can stop here, and yeah, before I stop, let me give you the quick update that yes, those who want to enroll for the comprehensive preparation, okay, you must have joined. And now guys, if you're looking for a quick crash course, okay, as well as crash full course, whatever your priority may be, okay, if you're looking for full course, that is also available for complete syllabus coverage. If you're looking for revision and crash course, less time में complete preparation, the complete revision in last 4 months, crash course is also available for EC as well as EE. Okay, where you will get in both the modules, you'll get live classes, practice quizzes, mock tests, recorded lectures, practice sessions, everything. Okay, so you can enroll now, or if you have any queries regarding to the course structures or the fees or anything, you can immediately contact this contact number, that is 924-133-666. I repeat, 924-133-666, and contact and get all your doubts sorted, guys. And yes guys, again, this is the link of my Telegram. I'll share my Telegram link directly in the chat box as well, and you will get my password, but you will get my PDF, but my PDFs are always password protected. So आज का password क्या रखें? What is the last concept we used in the flash type ADC? Encoder, randomly framed password. Okay, so all those watching the session, they get the access to the PDF, because you have watched, you have spent 2 hours, more than 2 hours watching this video, so you are okay eligible to get this PDF. Otherwise it is not useful for others, and that is why PDF will be password protected. Encoder, everything in small, please note down, encoder, everything in small, that is going to be the PDF password that I will share in this particular Telegram group. Okay, I'll share you the link of the Telegram group also directly, so that you can directly join using the link. Just a moment, so that you join using the link. एक बार check करते हैं. Yeah. All right guys, so initially what I thought is we will be covering digital circuits as I mentioned yesterday in 2 different parts. Okay, but I thought let's cover up IISc Bangalore all PYQs of digital 2016, 8 and 2 in one single shot. Okay, it's been more than 2 hours. Only one topic maybe I could not cover was logic family, but only CMOS logic family is there in the gate right now, and that too just less questions were there, just 1 or 2, but otherwise ADC, DAC, sequential circuits, FSM, combinational circuit, logic gates, Boolean logic, number system, everything we covered. So almost all questions are covered. I'm just honestly telling, except logic family, you can go through it because just there were 1 or 2 questions, but I think we are comfortably done with good amount of time, so it's time to stop now. Okay guys, that's it. The link is also there of the Telegram. You can join it if you want to get the PDF. I'll share you the PDF with the password protection as I mentioned. Bye bye, thank you, good night, stay safe and take care of yourself. The next session for you will be on Friday and that will be network theory by Sanjay Rathi sir. Okay, ये भी mention कर देता हूँ. Next, it will be directly Friday now. By all your favorite Sanjay Rathi sir. Okay, so you can watch it on Friday. ठीक है, Friday 7 PM. Friday 7 PM. Bye bye, thank you, stay safe and take care of yourself.